We're ready to get rolling with our next speaker. Mike Kent is an industry leader in MIDI and musical instrument industries. He's a member of the Technical Standards Board of the MIDI Manufacturers Association. He's co-author of the USB MIDI specification, principal architect of MIDI CI, and contributor to USB Audio 1, 2, and 3 specifications. And I know that's a lot of wonky stuff, but for those of you, especially my students, you know what that means. He had a 30-year career at Roland before starting his own consulting business. He's contributed components to MIDI for Windows, for Nintendo's Developer SDK, and he's worked closely with Apple on MIDI and audio solutions for many years. He contributed to an audio processing system for a NASA event simulation center and to audio capture for an archiving network for the US Coast Guard. Most of Mike's work is now focused on the future expansion of MIDI, working as a consultant to Yamaha R&D. Mike owns 19 synthesizers and 8 guitars. Please welcome Mike Kent.
Thank you. I'm nervous to know now that there are 10 people watching online. One of them probably is my mother. Okay, but before we start, I would like to take your picture. This is proof to my wife that sometimes people like to hear what I have to say. All right. Okay. So the topic for the next presentation here is MIDI. And MIDI has been with us, and we call it MIDI 1.0 because fundamentally it was invented 35 years ago, and we still use the same language to control musical instruments today. How many people here use MIDI? Everybody, every hand went up. Okay. How many people are experts in MIDI? Okay, half a dozen hands went up. All right, excellent. So that gives me some help to know how quickly to go through different sections here. All right, so history. I'd like to talk a little bit about how we got to here. And the arrival of digital technology in the musical instrument business that I come from was 1977. Ralph Dyke was a real pioneer just across the border in Vancouver, where I live. He worked out of Little Mountain Sound recording studios. He had a studio there. And he invented a sequencer that had a microprocessor in it. Mr. Kakahashi, the founder of Roland, met Ralph, and in 1977, they released the MC8, which was an update to his sequencer, and it was the first commercial musical instrument product with a microprocessor in it. So Ralph was a real pioneer. Another pioneer right around the same time as Dave Smith, who also happened to be building sequencers. And he released the Prophet 5, which was the first synthesizer with a microprocessor for storing memory and storing the whole patch of the synthesizer. Really a breakthrough instrument. Digital interfaces started to happen, so instruments were connected to each other with digital connections, and this was all breakthrough. And in 1981, Roland had a system called DCB. Oberheim had their system for connecting their synthesizers, and Sequential Circuits had a third one. And Mr. Kakahashi of Roland went to Tom Oberheim and said, "We're doing this thing, you're doing the same thing, but they don't talk to each other. How about we both agree to do the same thing?" And Tom Oberheim went to his friend Dave Smith and said, "What do you think of this?" And Dave got really excited about it. And Dave went and told the whole world, "Let's do this together." And you'll see that that's a bit of a theme through what I have here to say here about MIDI today. MIDI is a cooperative effort where even competitors got together and agreed on something and pushed the industry forward. And talking to other people that are in your industry is always a good thing. Belonging to the gang network is a good thing. So out of that came MIDI 1.0. And MIDI was actually, the language of it, the protocol, was almost basically DCB version 2. The hardware came from Dave Smith and Sequential Circuits. And those two things came together and formed MIDI. What else was I going to tell you here? I forget. Okay, it wasn't important, apparently. So I'll just go into the background of what MIDI does. It's a communication language where one device can talk to another device. So I've got the pink synthesizer down here, and if I play a note, it sends out a message saying, turn on that note. And another synthesizer will turn on the same note. And when I release my finger, there's a simple message that says, stop playing that note. So these are just note on and note off. And this is probably the most important MIDI message, at least for musical instruments. In addition to the notes and notes on and off, there's a couple of other types of messages that get sent. Selector here, there's a message called program change that allows you simply to select which sound or which function a device is doing. And then you've got controllers. And these are things like just turning the volume up and down, or bending your pitch up and down, or adding vibrato to a note. These are controllers. And these form kind of the fundamental types of controls that MIDI communicates from one device to another. MIDI has 16 channels. So if this pink synthesizer wants to talk to the green synthesizer, it can do so on channel 1, and the blue synthesizer will be set to receiving channel 2, and so on the pink synthesizer, when I set it to channel 2, it'll switch from talking to the green one, it'll switch to talking to the blue one. So we have multiple channels on one cable, 16 of them. These are digital signals that can be recorded with something called a sequencer. A sequencer is simply a MIDI recorder. Now, sequencers can record data. They can do all kinds of manipulation and editing on that data and then play it back to the device. And when that sequencer is playing the device, it's actually a real-time performance. The sequencer is sending, hey, play this note now stop playing that note. It's just playing back the commands that it has recorded or that you've edited. Similarly to the keyboard talking on different channels, sequencers can send on multiple channels. And so it can send a bass line to one type of synthesizer, the drum notes to a different synthesizer, and chords and melody to other synthesizers. And there are 16 channels for doing that. So these are kind of the core ideas of MIDI, which led to then different types of instruments. So if I'm using a system with a sequencer like this, maybe the blue and green synthesizers don't need all the keys on it. I can generate all the notes from my pink synthesizer there. And today we have plug-in synthesizers, which might be represented by these green and blue blocks up here. So the synthesizers don't all have keys on them anymore, but they did originally. We've also been able to move beyond just the keyboard. Now, MIDI does come from the keyboard industry. And so the note on and note off model works really well for keyboards. It becomes a little bit more problematic, but we've found over the 35 years solutions for using MIDI in other applications. And so typically a guitar with 6 strings will send on 7 MIDI channels. There's 1 MIDI channel per string, and then the 7th channel would be, master volume and those kinds of controls. This becomes important as compared to a keyboard to use multiple channels, because typically on a piano, I can't play 2 versions of middle C. There's only 1 key, and it's either up or down. But on a guitar, I could have a C coming from 1 string and up a few frets on the next string is the same C. And so I need to do that on multiple channels. So we found over the years ways to expand and use MIDI in new ways to do new things beyond its original design. Now back to history. It's funny that Brian talked about history in his talk this morning, and I have the same kind of idea. This is MIDI expansion happened. First thing that happened was personal computers were coming out at around the same time that MIDI came out. And Roland had the MPU-401. It was a standard MIDI interface with a little box connected to an ISA card to go into an IBM PC or compatible. Back when we used to talk about the PC as an IBM PC or compatible. It could plug into an Apple or a Commodore 64 and add MIDI functions to those personal computers. There was multimedia. Boy, did you know that computers could show pictures, and they could even be in color, or they could create sound, and it could do both at one time, a picture and sound together. These were the early days of MIDI in the late 80s and early 90s. Multimedia was a big part of driving where MIDI was used and the MIDI specifications. And General MIDI was one of the extensions to MIDI that came along that defined a default set of sounds. At that time, here's the MPU-401, by the way. MPU-401 connected to an ISA card or a card for an Apple or a little cartridge that went into a Commodore. And beside it here is a sound blaster. This is what you had if you played games and you wanted sound. You had a sound blaster sound card, and it had a Yamaha FM chip on board, the chip that Brian was talking about today, using the technology, FM technology from Stanford. And there's a joystick connector port on there. And some of the pins on the joystick connector were the pins that were used for MIDI interfaces. And so this is the standard way MIDI was done, was off of a joystick connector. And so MIDI advanced and moved into personal computer and became part of multimedia because of products like this. In 1997, Microsoft came to me and said, Mike, you know that MPU401 thing that you guys set the de facto standard for, and that Creative Labs, is putting into their Sound Blaster? It's an MPU401 compatible MIDI interface. That's going to go away because we're going to take away the joystick port. Other companies like Motu and Opcode were using the parallel ports and serial ports. They said, all of those are going away, and USB is coming. You better think about what to do with MIDI on USB. How's it going to work when the joystick port disappears? So technology forced us to adopt USB. So I went to Roland and said, hey, we're going to have to write a USB MIDI spec. And they said, okay, why don't you go do that? And so we worked with the USB Implementers Forum and with Microsoft and Apple at the time, and Creative Labs, and a few other companies joined. And we wrote the USB MIDI spec, and it came out in 1999. It's hard for me to believe that I actually started this work like 20 years ago. But USB added some things to MIDI. First of all, it allows MIDI to run at much higher speeds. MIDI was 31.25 kbaud. We don't measure things in kbaud anymore. And so it allows MIDI to run at hundreds of times the speed that it was originally designed for. So that's great. It also goes beyond the 16 MIDI channels, because we have 16 virtual cables on the one USB cable on what's called an endpoint. And so that gives us, on one device, easily 256 MIDI channels can happen on one device. And if I instantiate another endpoint, actually I get another 256. I haven't seen a device that needed more than 256, but it's possible. So USB added a bunch of things to MIDI, and MIDI continued to advance and allow us to do new things. Today, we can also run MIDI over a network using RTP, which is real-time transport protocol, which is built on top of UDP. So another way of running high-speed MIDI and running at long distances and in a network environment. This is often used actually with something called MIDI show control. And so you go to theme parks, a lot of things are run by MIDI using RTP MIDI. If you've been to Universal Studios in Southern California, I assume they still have the water world thing where the plane comes down and lands in the water, and there's fire and smoke and all of the systems there are controlled by MIDI. The fountains at the Bellagio in Las Vegas, they're controlled by MIDI as well. So RTP MIDI takes MIDI into new environments as well. More recently, we have MPE, MIDI Polyphonic Expression. If you've seen the Rolly Seaboard or the Lindstrom, it's called, from Roger Lynn, these use MPE, which allows more expressive music. So if I play a chord, I can add to just one note of the chord vibrato or a filter swell, or make one note swell up in volume as compared to the others. So MPE adds more expressive control. In fact, we've added a lot of things to MIDI since MIDI 1.0 came out in 1983. This is a list of the expansions we've made to MIDI. On this side is the confirmation of approvals list. I don't know, the name doesn't make sense to me, but these are new message specifications, new messages in MIDI. Okay, and on the far side, we have other specifications that are called recommended practices. And this is taking a set of messages, and let's all agree to use them in a particular way to solve a particular need, like MIDI show control. And so we've done a lot to expand MIDI. So while MIDI is still MIDI 1.0 language, and MIDI 1.0 is what we call it today, MIDI 1.0 of 1983 is not what we have today. We've done a lot. But we've added a lot within kind of a walled garden. We're kind of pushing at the walls. There's not a lot more that we can do for several reasons. First of all, users expect backwards compatibility. They want to use MIDI, the new MIDI devices they get, today or buy today with devices they bought 10, 20, and 30 years ago. And they just expect MIDI to continue, as it's done for 35 years, to mix old and new and have good compatibility. And the MIDI specification is actually fairly tightly defined in order to serve interoperability and compatibility. And so it's hard when you have a specification that is fixed to expand it sometimes. Common practices, we just know how to use MIDI. We like the way it works, and we know how to use it, so we don't want to change that too much. And so that's, as we get new ideas and the tech environment changes, we still have our ways of working that we like. And really fundamentally, MIDI has no opcodes left for new messages. We've exhausted all the opcodes, and things that we're doing to expand MIDI now today, some of them are a little bit, well, I'd call them hacks. And we have to hack MIDI in order to add things. And it's just becoming more difficult to expand. But today, MIDI works. In fact, it works really well. And so we've kind of come to the edge of the garden, and the question today is, are we done? I don't think we are. But the fact is there's some resistance to go any further because, one, it's difficult, and hey, it really works. You know, everybody in the room here is using it. Anybody not like it? There are times I don't like it, but generally MIDI works really well. So do we need to change? I'd like to take a fork in my presentation here for a moment and talk about the fork. The fork works really well. It's looked like this for about 150 years. A couple thousand years ago, they looked like this. Now, if they still look like this, they'd be good for poking your little brother under the table, but not so great for putting food in your mouth compared to the modern fork. We've built other forks along the way. Here's one with 7 tongs on it. Now, I'm sure that's really good for something, but I'm not going to use that to put food in my mouth. Okay, so there's other types of forks. There's other things you can do by controlling musical instruments that MIDI maybe doesn't do. But for what MIDI does, it does it really well. Do we need to change this? This has been with us for 150 years. Can we make the handle longer? Well, I now have to eat out here. Make it shorter? No, it works the way it is. So do you change the fork? MIDI works. Should we change it? Well, the fact is, there are some reasons why we might have to change it. And there are some reasons we might want to change it, but change it in the right way. Okay, so there's a push for change. First of all, users expect expectations and desires, and users vote with their dollars. You buy something because you like it, and therefore manufacturers sell you more of the same thing. Whatever you buy, they're going to make more of that. Okay, so MIDI works well, and people continue to buy MIDI products. And so we continue to make more. People want backwards compatibility, and so as manufacturers have to look at that and say, well, whatever we do in the future has got to work with the old stuff because our customers vote with their dollars, and they're not going to buy it if it breaks all their old gear. So users' expectations is a huge factor to weigh as we look at change in technology. Small one-man companies, this didn't exist in the earliest days of technology. Today, one man could do so many cool things. I'm prototyping new MIDI products just on an Arduino board. There's so many great tools, and one-man companies can produce great products, whether it's an app on an iPhone or some small MIDI widget. And one-man companies are really nimble. They can change direction of their company or very easily, very quickly. So they want to change, and a lot of innovation comes from small companies. Big companies, on the other hand, like Yamaha that I work for, and Apple, and Roland that I used to work for, those kinds of companies, change is difficult. Even though they're in the tech industry, major change is very costly. So there's new technologies all around us, and we want to take advantage of them, or sometimes we're forced to. Just like when Microsoft came to me and said, you better do something about MIDI because USB is coming and the joystick port is going away. We had no choice but to adapt. Okay? And to some extent, we're in the same situation with MIDI today. We almost have no choice because new technologies come along, and then those feed back to user expectations. Every device is going to be on the internet. They're all becoming connected devices. But your synthesizers today are generally not connected to the internet. And that's changing through a new thing called Web MIDI. And so there is technology change around us that pushes us forward, whether we like it or not. And then there are things that we want to do, like MP, that makes more expressive musical instruments so we can do more creative things. The technology moves ahead so that new creative things can happen as well. And so it's not just technology, but we keep in mind, fundamentally, this is about making music. MIDI is used for a lot of other things like the fountains at Bellagio, but fundamentally it's got to serve making music, and we can make music better if we have a better MIDI. Okay, so one of the things we have to consider in MIDI is the value of the existing knowledge. We've done an awful lot to learn how MIDI works. Users have invested. They've bought books in the past. There used to be a best-selling book called MIDI for Musicians. They must have sold a lot of books, and users today go online and read. You can watch YouTube videos on how MIDI works. The press invested an awful lot over the years. Magazines in the past, today, of course, mostly online. But there's a whole mechanism of serving information, and there's this value of knowledge that exists in MIDI today. The dealers know about it. Manufacturers went and educated all their dealers, said this is what MIDI does. And we have 35 years of this almost a pedagogy or existing knowledge that we've built up around MIDI, and we don't want to abandon all of that. In the early days of MIDI, when I joined Roland, we used to ship a MIDI cable inside every box. And so people would buy a keyboard, and they said, what do I do with this cable? I only own one synthesizer. I guess I better buy another one so I can use this cable and connect it up. But that was an investment that musical instrument companies made in promoting and educating about MIDI. And that cost millions and millions of dollars over particularly in the first 5 years. It was just a whole lot, very expensive. So we want to use the existing resources and knowledge. We don't want to change completely to something where we have to throw all of that existing knowledge base away. We want to innovate, but there's this thing, backwards compatibility. This is a theme that comes up over and over as we ask users. We've done surveys over the last few years from the MMA. What do you want out of MIDI, and what should we do to move ahead? And people say, hey, do cool new things, but please don't make it incompatible with my old gear. And so users have time invested and money invested in their gear. There's comfort in the workflow of how MIDI works, how sequencers work. All of those things we don't really want to change. And there's also, this is different from many technologies. When a new GPS comes out, you throw away the old one because you like the new one. And then when your iPhone does GPS, then I probably don't use the GPS in my car anymore. We're embracing new technology, but musical instruments are very personal to people. And I've invested a lot of time in this musical instrument. I have an emotional connection with it. So don't make me throw that away. Allow me to use that in a new environment. Okay, it's part of my creative being of who I am. All right, so these are all factors we consider as we look at future expansion of MIDI or changing the fork. 2 years ago, I had this idea. Now, we've had a lot of proposals made over the years to do new things. Some of them were very MIDI-like, and some were kind of like the fork with the 7 prongs on it. They do something really well, but it's a little bit different. And so there have been other proposals that come along, and some of those ended up being in MIDI as those recommended practices and so on. But some things have not worked out. I came up with an idea, and I proposed it 2 years ago, called MIDI Capability Inquiry, and I proposed it to the MIDI Manufacturers Association. And I basically, the idea is that MIDI is fundamentally designed as a one-way communication. I send you controls, and I control you from sender to receiver. What if MIDI is always a two-way communication? A USB cable, while it has MIDI data on it, it guarantees that two-way communication can happen. Whereas the MIDI cable was a one-way cable, and you had to hook up 2 of them if you wanted two-way. So if we assume two-way communication, can we do new things that we didn't do before? And the idea is that if 2 MIDI devices agree to do something new, then do the new thing. even if it somewhat breaks the rules of MIDI 1.0, maybe you can do something new. So you can agree to run at higher speeds than the 31.25 if both units agree. You could agree to use new messages that were not existing and couldn't be added to MIDI 1.0 if you both agree to break the rules and say, no, I'm going to add messages even though MIDI was out of messages. Okay, so this is the fundamental idea of MIDI capability and query. And I took that to the MMA, and Athan Bilius of Yamaha got quite excited about this. Several other people in the MMA thought it was a cool idea, but Athan was really adamant on this. And just like Dave Smith got excited about the idea of the synthesizer companies all using one common standard, Athan got excited about this, and he convinced Yamaha to continue with this. I just started a consulting company, so Yamaha hired me to actually continue to develop these ideas. So he convinced Richie Hasegawa, who was the head of technology at Yamaha at the time, to hire me. Richie Hasegawa also happened to be the chairman of AME, and I'll come back to AME in a minute. But Athan went and told people. So he went and visited Rowley and Moog, Steinberg, Arturia, IK Multimedia, Ableton, Motu, and very importantly, Apple, Microsoft, and Google, and said, we should all go and do these things and try to enlist support for the idea. And it's because these companies came along and said, yeah, we like that idea, that we were able to advance this in our industry. Some people said, I don't know. Dave Smith said, you know what, I really like MIDI. Now, it was his, okay? So he was one of the inventors, you know. He won a Grammy Award for it, you know. So maybe he has the right to say, I kind of like it the way it is. But go ahead and do your thing. And so we've moved ahead with MIDI capability inquiry. Yamaha, Roland, and Korg have all built prototypes as proof of concepts as we were writing the spec. They made prototypes to make sure it works. And AME is the Association of Musical Electronics Industry in Japan. MMA is in the United States, the MIDI Manufacturers Association. The two of them jointly develop new MIDI specifications. And so we took the specifications there. AME was on board immediately when Richie Hasegawa took it to them. And then AME proposed it back to MMA 2 months later, and they said, yeah, let's go for it. And the MMA formed a working group. 35 companies joined the working group to write the specification. And finally, the MIDI CI was adopted this January, actually in November by AME and in January by the MMA. So it's an official specification. All right, so what is it? What does it do for me? It really is laying just a framework or maybe a gate outside of this walled garden. It's the door to say, here's how we're going to expand beyond the garden that was MIDI 1.0. And so it doesn't actually do anything by itself. It just shows how to do it. Okay, so there are 3 Ps in the current version of MIDI CI. There is profile configuration, property exchange, and protocol negotiation. So I'm going to talk a little bit about the 3 Ps of MIDI CI. Okay, first one is profile negotiation. And here's 3 different instruments from 3 companies. Here's a traditional B3, which is now actually owned by Suzuki. If you buy a B3 organ today from Hammond, it's got MIDI on it. This is a Yamaha drawbar organ plug-in. This is a Roland portable synthesizer with drawbars on it for controlling its organ sound. 3 different instruments that do the same things. They have the same drawbars, and yet they don't talk to each other because they all use different MIDI messages for the same function. The idea of a profile is to define that the 8-foot drawbar will always be controlled by this particular message. And so we write a profile specification, and then MIDI CI allows 2 instruments to talk to each other and say, do you support the drawbar organ profile? And if the other device says, yes, I support the drawbar organ profile, then they agree to use that. And now, when I move the drawbars on my B3, they automatically move on my Yamaha B3 plugin. And I don't have to do mapping, which many of us have already learned how to do. Suddenly, these things just happen automatically. I have an example that is even worse than these 3 instruments. Yamaha, who I work for a lot these days, has 3 organs. They have an organ in the montage, they have that plug-in, and then they have the reface YC, which is a little organ with drawbars on it. And so that Yamaha has 3 organs, and none of them use the same messages. So even within one company, they don't talk to each other. But through a profile, devices that have similar functions, like the 9 drawbars, the percussion on-off, the 3 chorus, the 3 different vibrato selections on an organ, let's all agree to do them the same way. So this is the idea of a profile. And so here are the types of profiles that we expect to come. MIDI CI does not define these profiles. It just says how profiles work. Okay? So we still need to write these specifications. I've written already the drawbar organ profile, and I've written the rotary speaker one to go along with it in the effect profiles. So we have 3 main categories of profile configuration, or type of profiles. Instrument profiles are very typical instruments, and there may be probably, I'm guessing, maybe 30 profiles that would describe the common instruments like orchestral strings, brass, other than trombone, because trombone's got the slide thing. The rest of them, have valves generally. So there might be a brass profile and a trombone profile. Maybe they'll be the same thing. I don't know. Nobody's written that one yet. Somebody who's an expert in that area needs to write that profile. We need Roland and Yamaha, because they make MIDI-controlled drum sets, probably need to write the drum set profile. If you're an expert in one of these areas, why don't you write the profile for that area? We need effects. There's probably 100 effects out there. Distortions, phasers, flangers, compressors, multiband compressors. There's just a whole lot of profiles that can be written so that on a reverb unit, if I turn the reverb time on one, it also applies to another reverb somewhere else. So that I'm using commonality of messages, and things auto-map and the systems auto-configure. So if all of your devices and all your plugins support profiles, your DAW could say, who are you? What do you do? And a Yamaha piano could reply, I'm a piano that conforms to piano profile, and it could automatically pop up a piano editing window. And maybe I've got a plugin, and I've got an orchestral string sounds selected, and it says, oh, the profile's orchestral strings, and it'll give me things about articulation and string sections in an editor window. And then I switch the patch to drawbar organ, and suddenly that window goes away, and a drawbar organ window comes up. So automatic configuration is one of the core ideas of this concept of profile configuration, making things easier for the user. And I think that's really powerful and will really help workflow. So as I said, for user, easier configuration. And for manufacturers, profile configuration is actually quite simple, because they're already designing musical instruments with all of these controls. They just happen to all choose different messages to control these things. And so it's really, profile configuration is not a big challenge to manufacturers to do this. And it's all built around sysx messages, which we've used for 35 years. We know how to do this. And so this is an incremental step. It's not completely changing the fork, it's just refining the fork. And so it's a simple thing for us to do, and not too far away from what we already do today. Okay. Property exchange goes one step further than that. And property exchange is a set of messages that can ask far more detailed questions, like what parameter is controller 15 mapped to? Or do you have an amplitude envelope generator with a decay? You do. What controller do you want me to send for that? So you can ask very detailed questions of a device. You can also get large data sets out of a device. One of the ideas with property exchange is that we'll probably use JSON or some other technology, not standard MIDI system exclusive, which is really just a blob of data. But JSON becomes human readable, and it's very easy for us to then include things like text strings. And so we can ask for a list of all your patch names out of a synthesizer and get a list of the patch names, and then some meta tags to go along with that. So property exchange will do that. Now, the core ideas of property exchange are the ability to get and set properties. And get and set is used in other things. It's really never been done in MIDI before, but there's a lot of other things. HTTP has get and set type mechanisms and pings and so on. So we're going to borrow some concepts from other industries. There's no reason to invent new things. And so that's why one proposal would be that the language of this would be JSON. It's machine to machine. And so once again, we're going to help the user in configuration. So devices can talk to each other and self-map or self-configure, or a DAW can configure to support very detailed features of a MIDI device, whether that's in hardware or in software. This does present some new fields for manufacturers. You know, MIDI manufacturers may not have done JSON ever before. So there are some new things here, but it's not too far away from the technology that many of us are using today. So it's a reasonable step and a reasonable addition to MIDI, and is going to do powerful new things and help workflow in particular. The last area, the last P of the 3 Ps is protocol negotiation. And this allows devices to select the protocol they're going to use. And this is potentially one of the biggest areas that's going to allow new creativity, not just ease of use and better configuration, but new creativity. And so the idea is the ability to negotiate the language you're going to use. You're going to use either the MIDI 1.0 language or the new MIDI protocol that is currently being defined, and we're simply calling next generation protocol at the moment. So devices can decide and agree together what language they're going to use to talk to each other. And so therefore we can kind of break the rules of MIDI 1.0 and say, well, MIDI 1.0 language said that it had to be done this way. So we can break some of those rules and do new things that you could not do with MIDI 1.0. We can do them in a next generation protocol. By the way, you do have the ability also to switch to something completely manufacturer specific. So if you want your device to generally do MIDI, but every now and then go away and do something that's not MIDI-like at all, then you can go and do that. And then negotiate back to using MIDI again. And so protocol negotiation is part of MIDI capability inquiry. It comes with a test for compatibility. So when you switch to the next-gen protocol, the two devices that are talking, one of them sends a test message. If the other one receives it and everything's good, it sends back a test message, and the second one receives it, and then the two devices know that they're talking successfully in the next-gen protocol. If something doesn't work out after a timeout, both devices fall back to being MIDI 1.0 language. And so this preserves compatibility. If I take a new product and connect it to an old product, and I plug it in and I say, can we use the next-gen protocol by hitting a configure button on it or something like that? It talks to the old device doesn't know anything about it, then this device times out and says, okay, we're just going to use MIDI 1.0. And that looks after backwards compatibility in this test mechanism. Okay? So protocol negotiation, again, we don't define the new protocol in MIDI capability inquiry, we just tell you how to get there. Okay? So let's take a look at what this next-gen protocol might look like. One of the things that we've done as we're writing the next-generation protocol is it has to use the existing semantics and mechanisms of MIDI. So remember, as I told you, MIDI 1.0, one of the fundamental ideas is I press a note and it says start playing a note. When I stop playing a note, it says stop playing that note. We don't want to change that mechanism. We want to use the mechanisms and architecture that MIDI has always had and keep them. And so the next generation protocol is really more MIDI, which is, you'll see the bottom slide. It really is MIDI, but with more. It's incremental change. It doesn't change everything wholesale to something completely new. It's a step-by-step expansion, and there's room for more expansion later. But in its first version of next generation protocol, it looks an awful lot like MIDI 1.0. But there's a whole lot of room for expansion, whereas MIDI 1.0 was this walled garden. We've now moved out of that to a much larger space that's far more expandable. Backwards compatibility is important. So in addition to this negotiation compatibility that I told you about, just translation from the new protocol to the MIDI 1.0 protocol is important. So if I record something into a sequencer, or record a performance into a sequencer, and later I change it so that it's going to play back on another device that's a MIDI 1.0, I don't want to have that being completely meaningless. I've got to be able to translate that and have something meaningful come out on the other device. Okay, so translation is an important part of, or a requirement of this next generation protocol. So I said it's more MIDI. So what is the more? We want to do higher resolution. MIDI is a 7-bit data language. Everything is 8-bit words, and you only get to use 7 bits of it for data, because the first bit is a status bit on every message. So we want high resolution, and today computers use 32-bit or 64-bit resolution for their data. And so we want to be able to support 32-bit resolution. 32 bits is probably overkill for a lot of properties or parameters, but we want to be able to support up to 32 bits. And so we want higher resolution. We want more channels. And so we're going to provide you more channels and more controllers. And I'll come back to more controllers on the next slide in a minute. Something that MIDI doesn't have is per note controllers. And so MPE gets around that, and MPE is actually a little bit of a hack in order to get per note controllers. And so we want to be able to take that concept and make it native to the next generation protocol. And so we've added per note controllers and per note pitch bend, so that I can detune one note from the rest, or bend a pitch from this note to this note. So per note pitch bend is a new addition to MIDI. So those bottom two, they're a little bit unique in that the top things here, high resolution and so on, those things translate back very well to MIDI 1.0. These bottom two probably don't translate back to MIDI 1.0. So not everything's going to translate back. You can't do something completely new and have it, the old things completely do the same thing. Otherwise, they are the same thing. So these are some new functionality here. We have articulation control. If you're scoring an orchestral score and you're using a strings library and a plugin, you know you've got switching between bowed, pizzicato and spizzicato on your violins and so on. And so we want to have articulation control in your note messages and be able to do that. And so that's part of the protocol, so that we all start to do those things in the same way. If I use somebody's string library and use their articulation controls and then load up another string library today, the articulation controls don't necessarily match. They're done in different manners. And so we want to standardize articulation control in this next generation protocol. Expanded tuning capabilities. MIDI 1.0 was designed around a 12-tone equal temperament scale, the Western scale that we generally use in this country and in our Western music. But there's a lot of other music and there's a lot of other tunings. And so MIDI does actually have something called MIDI scale tuning, where you can do non-Western scales. But we're expanding on that in the next generation protocol and allowing far more ways of using tuning. And I'm excited about this. Just to get musical, how many are music students here? Okay, we got a third of the room is music students. I'm thinking I'm in the key of G and I play a D augmented chord. Where's that D augmented chord leading? If I'm leading from that, and I look at the top note of that augmented, the augmented note is an A sharp. If I tune that a little bit sharp above equal temperament, it starts pulling even harder up to the B that it's kind of hinting at moving towards, right? I want to be able to do that kind of thing. Or in that same augmented chord, the D augmented in the key of G, if the next chord is going to be a C major 7, going from the 5 augmented to the 4 major 7, I'm going to take that D and maybe make it a little bit flat and see if that helps pull towards that 4 major 7. I want to do those kinds of things and experiment with the tuning of my chords. And that's musical creativity that comes out of expanded tuning capabilities in the next gen protocol. And I'm really, as you can tell, I'm excited about those kinds of things. Simpler NRPN and RPN. I don't know has anybody ever used NRPNs or RPNs in MIDI? No. Anybody know what it is? Cord Taylor probably does. Dave does. NRPN, we ran out of controllers. There was only 128 of them. And so we ran out and we said, okay, well, we need more. And so what we did said, we'll use one control change messages as the most significant bit of a new address. We use another controller as the least significant bit of that address. So now we have a 14-bit address space. And then we'll send controller number 6 as 7 bits worth of data, the MSB data of the actual value that I want to set at that address. That's the MSB. And then controller number, what is it, 37? No, 38. Is the LSB I'm going to use for that value. And then I'm going to send a clear message at the end of that to say I'm finished controlling that one thing. So I send 5 messages to accomplish one change. It's really complex and basically has not been implemented very well, even by companies who do know MIDI very well. It's not been implemented very much at all, and therefore none of you are using it because your tools don't allow you to use it, because even the tool manufacturers say, man, that's ugly. So we want to fix that. So NRPNs and RPNs become one atomic message in the next generation protocol. It is just a message. It's controller, and here's the index or the address, and here's the value, which is probably 32-bit value. And it translates back perfectly to RPNs and NRPNs in MIDI 1.0, but they're unwieldy to use there. They're really easy to use in the next generation protocol. So that's a big improvement over MIDI 1.0's structure at expanding its controllers. So that goes back to the first slide where I said more controllers. It's actually not more controllers, it's the same amount, just where you're taking the 32,000 of them that were unusable and making them really usable. We're also making an atomic message out of bank, select, and program change. Bank select is, again, 3 messages. There's an MSB of your bank and then an LSB of your bank, and then you send a program change to select your sound. Because program change, there was only 128 of them. On most synthesizers, they have 1,000 or 2 or 10,000 sounds. And so we needed to expand. So MIDI didn't allow for that in program change, so we defined this bank select idea where we're using a control change message now to set an address. And so it's a little bit unwieldy in MIDI 1.0. It works, but it's a little bit unwieldy. Fortunately, a lot of DAWs look after that unwieldiness for us and give us just lists of patches and so on. And so that's a lot easier. But we want to make all of that easier even for the DAW manufacturers. And so we have a simpler bank and program change would be a requirement of this next generation protocol. The next thing is improved musical timing. And timestamps is something that can allow us better musical timing. Just by adding higher speed on USB MIDI, we can improve timing. So in MIDI 1.0, running at 31.25, if I want to play 10 notes simultaneously, all on the downbeat, I send the first one, and then the next one, then the next one, and the next one, and the next one. And the last one arrives several milliseconds after the first one. Okay, so I got this jitter. When I try to play everything simultaneously, it doesn't come out simultaneously because it's a serial port that's slow. If I run that a lot faster, the last one arrives much closer to the first one. And so just by running faster, we get better timing on MIDI. But timestamps has allowed us to capture a performance with high resolution. So if I've got a great performer, Oscar Peterson on the piano. I used to work with Oscar. I was his tech support guy. He'd record into sequencers his playing on the piano. And we have captures of him playing, but it's all got this time skew where he played, he had massive hands. He put his hands down like that and cover 4 octaves on the piano. And so he'd play these massive chords, and all those notes, when he played them, happened simultaneously. But the recording didn't necessarily get it that way because over MIDI, some of those notes were skewed later than the first note, right? So with timestamps, the piano can say those things all happened at the same time and send every one of those notes out with a timestamp that said, these things all happened together. And so when you play it back from the sequencer could say to the rendering engine, these things all happen together, so play them together. So we're going to get better musical timing out of this next generation protocol through the addition of timestamps. I can't really tell you a lot more details than that because when it comes to writing these specifications, it's done within the MIDI Manufacturers Association, and these things are actually confidential. The actual design of this and how it's all done is confidential until the specification is released. If you'd like to participate in this, you can join and participate, but then you sign a confidentiality agreement. So this is about all I can tell you about next generation protocol without getting in trouble. And I know some people watching online right now might even be saying, I think you're sharing too much already. All right, so to review, MIDI CI has the 3 Ps: profile configuration, allows me to auto-configure various instrument types or effects types. Property exchange is a get and set mechanism to dig deeper into details or to get large data sets out of instruments. And then protocol negotiation. Now, I'd like to just cover these three a little bit in terms of backwards compatibility. For profile configuration, if two devices talk and the device on the other end says, I don't support any profiles, it doesn't break anything. MIDI 1.0 can still continue to work just fine the way it always has. So profile is just something that we add that devices support or don't, and if they don't, MIDI continues to work just the way it always has. Same with property exchange. If a device doesn't support it, it doesn't support it. You just continue to use MIDI 1.0 the way it was. Protocol negotiation is a little bit different in that we have a test for the new next generation protocol. So two devices agree to use it, and then you switch there. Then you do a test. If the test fails or it doesn't get completed within a certain timeout, then the devices both revert back to MIDI 1.0, and they have an agreement that they're going to do so. And so they revert to MIDI 1.0, and you continue to use MIDI the way you always did. And so while we advance and step outside the gate, we have ways to say, no, this thing belongs back inside the walled garden. And we look after backwards compatibility. I mentioned this as well. Down the bottom here, you'll see MIDI 1.0 protocol and the next generation protocol. And translation between these two has to be simple. There has to be the same concepts of node on and node off need to exist in order to make easy translation. So the next generation protocol, as I said, looks a lot like MIDI 1.0. It's just more of the same. So I asked the question earlier, what's next? What's next really is just more MIDI. It's not something completely new. It's an incremental step. MIDI CI allows us to step outside the walls that we have so far and start to do new things. So what do we need to do? What are the actual action items that are going on right now? First of all, profile configuration. We're defining profile specifications for common instrument types. If you're an expert in an area, Cord, I'm talking to you right now about profiles for tuning. Maybe you should write a tuning profile specification. Property exchange, we need to define properties and then standard applications. So we're defining applications for getting patch lists, all in text and meta tags and so on. And we're defining those kinds of things in AME and the MMA. And we're defining the new protocol specification. In fact, we're pretty much done with a new protocol specification. And this past couple of weeks in the MMA and AME, we agreed that we're basically done, and now we're going to do proof of concept prototypes. So we're going to build some products that implement the new protocol, test it for the next 6 months before we vote and say, yes, it works, and then release it as a spec. Or after 6 months, find out that everything we invented is terrible and prototypes show that we shouldn't do it that way. So that's where we're going. So what can you do? Join the MIDI Association. It's free. Go to MIDI.org and join the MIDI Association. And there are discussion forums there. You can discuss all of these ideas. If you join, you'll get emails every now and then telling you about the latest things that are happening in MIDI. You'll find out when new profiles are released. You'll find out when things are happening. If you actually want to define specifications, then you join the MIDI Manufacturers Association, also found at MIDI.org. So there are things that you could do. Everybody in the room should at least join the MIDI Association. If you use MIDI, you should join. It's a lot of fun and it's free. All right. That's it. Any questions?
Questions? I'm going to go to Brian Schmidt.
Hey, Mike, that was great. In looking at your presentation about the protocol, parameter sets, it seems like it's a very similar problem that the Internet of Things has. Like you could easily see configure profiles for door locks, profiles for refrigerators or thermostats. Are there any other protocols that are out there kind of trying to solve this similar problem that you're aware of that you might think about incorporating into this? Or is there like a secret plan to have MIDI CI take over the Internet of Things?
There is actually a plan for MIDI to take over the world. AME did a presentation at the NAMM show where they showed MIDI-controlled robots, a MIDI-controlled toaster, which was a bit of a joke, but just the idea of appliances being controlled by MIDI. Like the fountains at Bellagio are controlled by MIDI. MIDI is a pretty simple language. It's not expensive, it's not heavy, and there are applications and there are reasons you might want to use it. And so one of the things that we want to do with profiles is expand MIDI to non-musical instrument control. So for example, I don't know if any of you saw the Intel keynote at the Consumer Electronics Show. They had a performer on stage playing a piano, and then they had AI listen to what he played and play back some music in the same style and so on. And they had these huge, like 50 feet tall graphic performers that were being controlled by MIDI. And so imagine a holographic performer sitting in a piano, and that performer is controlled by MIDI. That allows the holographic performer to be on the same data stream as music, and where the clock messages are for the beat timing and so on. So in fact, our interest in profiles is probably to take MIDI to other things rather than but we don't want to ignore what's happening elsewhere, which is why we're looking at JSON for part of property exchanges. JSON's a perfect way to get and set properties. How are we going to store this stuff? Cord asked me this earlier today. What about storing all of this new information? And there's a standard MIDI file, which is a unique file format for storing MIDI. But maybe we should be looking at, if we're doing new things that include JSON and other new types of messages, maybe XML is a better way to store MIDI in the future. So we are definitely, AME and MMA wants to be outward looking, and we don't want to invent things that already exist. It's much cheaper to a lot of the stuff is just driven by dollars. It's a lot cheaper to borrow an idea that's already done elsewhere.
I'm really curious what you think about open sound control.
Open sound control is really cool. It's a little bit like a slightly different fork. It's maybe the dessert fork of forks or something, It's different from the standard fork. The problem with open sound control, if there's a problem, is that it's a little bit unlike MIDI. And therefore, it's a step further away. It's harder to translate it to MIDI. It's harder for manufacturers to build products using all their existing investment. All the testing tools that they have for MIDI don't necessarily apply to OSC. And so OSC has been somewhat unsuccessful because a little bit too far away from MIDI. And also a couple of times I mentioned, when I wrote the USB MIDI spec, I went and visited Motu. I went and visited Opcode. I went and visited MIDI Man, which became M Audio, and said, hey, this USB thing's coming. You're going to be implementing this, and this is what I'm doing about it. OSC was not really well presented to manufacturers. Same thing with MIDI CI. It was Athan Billies who went and presented it to all of the manufacturers that count. I went with them at times, and Ben Israel from Yamaha was active in this, and the AME companies were all active in this, and various people started to spread the news. An OSC just really wasn't sold well to manufacturers, and so it hasn't caught on with the core musical instrument companies, and it's for two reasons. Yeah, it's a bit far away from MIDI, and it wasn't sold well.
Thanks.
What is the state of audio to MIDI? Say, with the ability of people to play instruments and have audio, then interpret MIDI data or convert into MIDI data.
Sure. So really, the audio to MIDI has been done for a long time, for many years. Guitar controllers do audio to MIDI. And there are newer technologies in the last 5 and 10 years that have come about that actually can do it from a polyphonic source. Or listen to a wave file and figure out the chords that are being played at least. And so some of that is happening. And I think the new next generation protocol will help us in that regard, in that it allows us to define new messages that possibly are tied to that. One guy has proposed a perceptual pitch profile. And so on many instruments, they start making a sound, but at the very beginning, it's just noise. There's no pitch. And as time goes on, over a number of milliseconds or whatever, a pitch becomes more and more clear. It becomes less and less random until a fundamental note comes out with all of its harmonics above that. And so he wants to write a profile for defining that kind of a transition from a note that has no pitch to a note that has pitch. And I think profiles are going to be great helpers to do that and allow us to do those things in a common way. It's great for one manufacturer to innovate and do something. And some manufacturers, their business is built around, I'm doing it and I'm doing it my own way and nobody else can share with me. MIDI was successful because Oberheim was willing to give up their system. Sequential Circuits, Roland were willing to give up their systems and say, no, let's use a common one. And that became the bigger business. There's a business model for doing it a different way. So I'm not saying companies shouldn't do that. But by and large, the business is going to happen when we agree to do things the same way. And I think profiles will be a big part of that audio to MIDI moving ahead and being more and more viable as we do it all the same way and learn from each other and compete with each other in doing so.
We're going to take one more question here, and then I think we're going to move on.
Hey, my name's Ben. Great talk. You mentioned the progression of sort of a MIDI fork from the 5-pin DIN connector to the USB connection. I wanted to know what your thoughts are on wireless MIDI connections, since it is zeros and ones, and the feasibility of that.
Right. So RTP MIDI is also already doing wireless. You can do wireless MIDI over RTP, and in fact, I think Mac OS, OS X, and iOS both support RTP MIDI wirelessly. And there's also a new specification that we put out a year and a half ago now, BLE MIDI, Bluetooth MIDI, and that works really quite well. And so you'll find that in a bunch of products now, wireless MIDI there. Wireless always has a couple of problems. One is lost packets. And so you need a protocol that's going to look after that. And one way you look after that is by adding latency. And wireless generally is high latency. So while a 5-pin DIN cable can get a single message across in a third of a millisecond, on Bluetooth LE to send one message, it depends on the service interval of the Bluetooth devices you're using. And I believe a Mac, like my MacBook Pro here, its service interval I think is 11.5 milliseconds. So my average latency is going to be 11.5 milliseconds before something happens. So wireless adds latency on top of the latency that's already there. If I'm playing a keyboard, from the time I press a key to the time it actually gets put on a bus, whether it's the 5-pin DIN or Bluetooth or RTP or whatever, there's some latency in the keyboard to actually make that happen. And then it arrives at a synthesizer, or maybe it arrives at an OS, and like Core MIDI gets the message through a driver, and USB has its latency, and so on. There's always latency, and the wireless latency is added on top of latencies that already exist in the system. And really, the wireless technologies that exist today are really great for things where real-time performance is not critical, and where real-time performance is like playing a keyboard over Bluetooth, we're really just on the verge of not really friendly and playable. But it does work, and for most people, it's good. A great player can tell the difference between a USB MIDI connection and a Bluetooth connection because the latency's there.
Mike, thank you so much. Let's have another round of applause for Mike Kent. It's a fantastic talk.